So, hello everyone, welcome back to Imaginary Hub. This is going to be our first lecture on DSA, and in this session, we are gonna talk about our very first data structure, which is arrays. So, before I go into what is array and all those sort of things, in the previous class, in the introduction class of DSA, I have told you to I have shown you how we can create a Java program, how we can create variables, what is a variable, and all those sort of things. So before we jump into how array works, how to create array in our program, everything, let me give you a little recap on what is a variable and how a variable works in the memory. So let's say I'm creating a variable int a is equals to 10. My handwriting is very bad, I know that, so for now just keep it. So when I write int a is equals to 10, what I'm doing is that I'm creating a block in my memory. So what will happen in the memory is that a block will get created and the name of this block will be a, and this particular block will have a address in itself, and address can be any random number, right? 2008, something like that, and through this address we can access the variable name, and through variable name we can access whatever the value which is there inside this particular variable. Right now we are having 10 in our particular block, in our memory block, in our variable. Okay, and this particular whatever the data we are gonna store, we call that data as the data type of that particular variable. For example, let's say I'm creating a string yes is equals to something. I'm gonna store, let's say, Jabir. I'm storing Jabir. Now a block will get created. Actually for string, separate thing will happen, a heap and a stack will get created, but we can imagine this as a form of a block. So here we'll have the name of the variable, which is yes, and in that I'm gonna store Jabir, and this particular string will have its own address. Let's say it will be a very random number, 2014, something like that. Now through address you can access the variable, through name you can access the value of that particular variable. This is how memory allocation happens for variables. Now here is the thing, like array is a linear data structure. So let's go into directly into array. So array is a linear data structure, which is used to store a list of elements at once. For example, to visualize why we use array, what is the need of array, let us imagine a case that I want to store the marks of a particular student. Let's say there's a student, his name is Jabir, and he has different subjects, like he has math, physics, chemistry, biology, all this sort of things, right? So each subject will have marks, and we already know that for each subject the data type, the marks will be a integer. Now to store the marks of Jabir for each subject, I can create separate variables. For example, I can create int math is equals to 90, int physics is equals to 100, and similarly int chemistry is equals to 80, int biology is equals to something 85. Now I can create this, but you can see that I have created four blocks of memory separately, right? And this memory allocation, whenever we are creating different variables, right, memory allocation happens very randomly, right? 2009, 2024, 2039, 2069, like this randomly memory allocation will happen, first point. And the second point here is that the number of lines, we are writing 4 lines in our code, right? So what if there is a data structure where I can store all these variables in a continuous fashion, and the data type of all this variables of all these blocks is continuous, is not continuous, is same? We call that data type as array. So what is the definition of array? Array is a linear data structure in which we store homogeneous data type in a list in a continuous fashion. This is the definition of array. So instead of writing 4 different lines, you can do the this same process using arrays. So what I will do is that I will create a list of elements, right? In this list I will insert my marks. So what I will do, I'll create an array, like let's say I want to create an integer type array. So I will write int arr is equals to, and let's say I want to store max marks, so 90, 100 and 80 and 88. Like this I can store the variables, I can store the marks of a particular student in a single array. And how many lines I'm writing 1 line. In the above case I'm writing 4 lines. So the number of writing lines has reduced. And second advantage is that whenever you are creating variables now, the memory allocation happens very randomly. But when it comes to array, the memory allocation happens in a continuous fashion. For example, let's say 90 is a variable, 100 is a variable value, 80 and 88. So what will happen is that instead of having distinct blocks of memory, we will have a continuous blocks of memory in our computer, right? Whenever we are creating it, continuous memory allocation will happen. So here you can see, let's say the memory address of this is 2024. I think the size of int is 4 bytes. So immediately after 4 bytes, 2028, at address 2028, the next variable will come. After 2020 32, right? 32 and 2036. Like this, in a very continuous fashion, memory allocation of different variables happens. So what is the advantage? First point is total number of lines, or you can say it is more efficient. Instead of writing n number of lines, we are reducing this n number of lines into 1 or 2 lines, right? Whenever we are creating, this is the advantage. Now the next advantage is that whenever you are performing retrieval operations, right? While performing retrieval operations, because for variables the memory allocation happening in a very random way, but when it comes to arrays, the memory is happening in a continuous fashion, so the retrieval process is also very fast. So these are the two advantage. So the definition of an array is, it is a linear data structure. It is like we have two types of data structures. One is linear data structures, another one is non-linear data structure. We'll go into what are non-linear, linear, but let me give you a little overview, right, at the same time. So we have two types of data structures, right? Two types of data structures. One is linear data structure. In linear data structure we have arrays, array list, linked list, right? So these are linear data structures. Non-linear data structures are graphs, trees, binary trees, binary search trees. These are non-linear data structure. We'll study each one of them in detail. The very first data structure is arrays. We are going to study arrays. So I hope you have understood why we use arrays. First point, it will reduce the number of lines. Second point, because it stores elements in a list, elements in a continuous fashion, such that the allocation and retrieval time is really fast when compared to random allocation, right? These are the two things. And I have shown you just now example, like creating array of marks of students. This is a example of array. Now I hope you have understood how to create array, why we use array. Now let us talk about one more thing, accessing elements. So I have two cases. I will write two cases here for our simplicity. In case one, to store user marks, like Jabir marks, to store Jabir marks, I am creating three different variables. Int math is equals to 100, and int physics is equals to 100, and int let me go here, okay, int chemistry is equals to 100. I'm storing this. This is one way of storing marks of a particular student, right? I'm taking this example because it's really easy to understand it. Now in case 2, what I'm doing, in case 2, I am creating array, and in this array I am storing elements. So what I will do to store Jabir marks, I already know that the first element is math, the second element is physics, third element is chemistry. So what I will do is that I will create an array int marks is equals to, here I will store 100, 100 and 100. So as you can see, number of lines has reduced and allocation is continuous. Okay, got it. Now the next thing is key how to access elements. In case 1 I already know, I will write system.out.print. To access math marks, I'll just write math, and it will give whatever the in math block, whatever the value is there in math block. Right now the value is 100, so I'll get the value as 100. When I print this will give me 100. Now the question is how we can access the elements in a particular array. So you need to understand that there is something called as indexing, or you can say index. Through index you can get the elements present in that particular array. So we already know key memory allocation happens in a very continuous fashion. So 100, 100 and 100. So to access a particular element, here we are using the variable name, but in this case we don't have any variable name. So in this case what we do is that we can access the elements through indexing. There is something called as index. Each element, each block in the array is associated with a number, right? Through this number we call this number as an index, and through this number you can access the elements in the array. Okay, so here when I'm writing 0, 1, 2, so let's say and we start in Java, we have zero base indexing. Remember this thing, zero base indexing. Okay, I hope till now everything is clear. To access elements for variables, we write variable name. To access elements in the array, what we do is that we'll write system.out.print, and let's say I want to access the math marks. So what I will do, I'll just write the array name marks, and in square brackets I will write whatever the index I want. Let's say I want to and access the element at the 0th index, so I will write 0. That's it, and this will give me math marks, which is 100. Okay, now if I want to access the chemistry marks, so I already know the chemistry marks index is 2, so I will write marks. Here I will write 2, and this will give me 100, which is chemistry marks, right? Like this I can access the elements. I can access and print the elements as well. Now here let's say Jabir, I have entered something wrong marks for Jabir in max, and I want to change it. So I can easily change it. I already shown you ki kaisa change, like how we can change the variable value. So here I will write math is equals to 98. I'll just write it, and automatically that particular block value will get changed to 98. Similarly, here you can change the values in the array through its index. So here I will write marks of 0. Right now it is 100. I'm gonna change it to 98. So what will happen is that here 100 will get changed to 98. So our new array will be 98, 100 and 100. Like this we can even change the values through index. Okay, got it. So I hope you have understood the theory part of it, like how we can create it, what is the use of it, why we are using it, how to create it, and what will happen in the memory, how we can access it, what is zero base indexing, everything. Now what we'll do is that let's stop theory, let's go to the code, and I will show you how things work, how to create array, how to access elements and all those sort of things. So I'll just go to Visual Studio Code. Here let me zoom it. So here you can see I have a DSA folder. I have opened it, and I hope you guys have also created a DSA folder. Now what we will do is that in this folder I will create another folder. Let's say arrays. We are studying arrays, right? So in arrays I will create a file called as introduction.js. Okay, sorry, Java, my bad. introduction dot Java. So what is the first thing we should do? We should import our boilerplate code. I will write import. Let me remove this capital. So import Java dot util dot star. After that, I'll write public, my public class, public static main, and let me remove all these things. This is auto suggested because I have downloaded like GitHub Copilot, right? So it is suggesting me automatically. I'll remove everything. So yeah, so you can see I have like written my boilerplate code. Now what is the first thing? How to create an array? So let me show you creation of array. Creation of a array. Okay, so there are 4 ways to create array. The first thing is you can directly write int arr square brackets is equals to, and in the curly parenthesis can do 1 2 3 4 5, or here we are storing marks, right? So 99 100 and 99, math, physics, chemistry. Like this you can do, or else you can also do the second method. Like here I'll write int arr1 is equals to new int of, here I'm gonna store 5 elements, right? So here I'll give 3. That's it. Oh, sorry, we are having 3 elements, right? Math, physics, chemistry. So I'll write 3. So here what I'm doing is that I'm creating an array arr1. The name of the array is arr1 is equals to new int, and here int of square brackets, and I'm giving 3. What it represents? 3 represents the size of the array. Now the array is empty. If I print system dot out dot print arr of arr1, okay, and arr of 1 of 0, it will give me error or it will give me null. Okay, just let me run it. Where is the run button? Every time I have to search for this run. Okay, run without debugging Java. Okay, let me run it myself. So I'll go to cd array, and I'm in capital array, right? So cd arrays, cd arrays. Now I'm in my arrays. What I will do is that let me run my Java file. So Java introduction here, everything is capital, my bad. Introduction dot Java. So when I run it now, it will give me an error. You can see error package system does not exist. Here I need to give capital S. So capital S system dot out dot print. Let me give capital. Okay, capital. Now let me save it again and run my command. So you can see I'm getting arr one of arr one of 0th index is 0. Now if I print arr of 2, I'll get the same thing, 0, because initially whenever you have declared array but in that you haven't assigned anything, in that case every index will store 0. Every element will store 0 in the array. Now what I can do here, I can give the max marks. So first of all I will give math marks, which is arr of 0 is equals to 99. After that is equals to 0. After that I will give my physics marks. After that chemistry marks, right? Chemistry marks. So I have given 99 100 99. So when I print it now, I will print arr of 0, arr of 1, arr of 2. Okay, I'm printing it, and let me remove it. Here I need to give arr of 1, not 0, 1 of 1, arr of 2. So here when I give this, let me save it first. Let me save it and clear my terminal, clear, and run it again. You will see 99 100 99. So what is happening is that initially in each and every index it will store by defaultly 0. When I'm explicitly assigning, in that case that particular value will get inserted in that particular block. Like this the assigning and creation of array will happen. Now let us see how we can take elements from a particular user. So right now we have created the integer array. For now let me create a float array. So I'll write float, or in the place of float what we can do, boolean will not work. Okay, you can create, like for example here I have created an integer array. Now let's say I want to store a string, so I will write string str array is equals to apple, mango, banana. Like this I can print the elements, I can print, not print, I can create the elements, right? And here I'm going to store strings. If I'm writing float, I'll store float values. Remember, for array in Java the element should be homogeneous. If I'm creating an integer, then in that case I cannot store a string, I cannot store a float, I can't store like boolean value. Let's say I'm creating a boolean array. So boolean is true, is prime is equals to true, false, false, true, something like this. So here a integer element will store integer only, an integer array will store integer elements only, and a string will store, string array will store strings only, and boolean will store booleans. That's it. Okay, now we have understood how to create different data type arrays, how to print arrays, how to access them, how to assign them. Now let us see how we can take input from the user. So scanner sc is equals to new system.in. Okay, now take input from user, we have to write this scanner class. Now after writing this, we already know to take variable input, we'll write sc.nextend. Now similarly, to take input of a particular array, what we'll do is that first of all we'll declare the array. Now after declaring, we'll run a loop, and inside the loop we'll access each and every element, and for that particular element we'll ask user what value you want to insert. So here I'll write system.out.print, and yeah, close this parenthesis. Okay, now after that I'll print system, or I'll run a loop again and I'll print it. Okay, so let me save it first, and so let me save it and comment this all things. Let me remove all these things, I don't want this thing, so I'll just comment it out, and let me remove this comment. And okay, I have commented unnecessary things for now. So understand the flow, what is happening here. First of all, we are taking the input of a, we are creating an integer like scanner class, and I have created the array, and the size of the array is 5. So we are going to store 5 elements: math, physics, chemistry, biology, social. Now after this I'm running a loop, and I'm iterating each element, right? I'm accessing each index, and in this particular index I'm inserting the value, whatever the value given by my user. Okay, first loop is doing that work. Now when I come out of first loop, what I'm doing here I'm printing that particular array value. So here, after storing each and everything in this 5 elements, I'm going to each and every element and I'm printing the value inside that. Okay, so let me save that and run it again. Java introduction.java. So I need to give the first element. Let's say math marks is 100, physics is 100, chemistry is 99, biology is 97, and social is 80. So when I enter now, you will get math marks, physics marks, chemistry, biology, social, and I can give some decoration things as well if you want, like system.out.print, print in marks, like this, and save again. It will look good. Okay, now 100, 99, 98, 89, EID. So you can see printing marks, and I'm printing marks like this. So I hope you have understood key how we can take input, creating elements, and everything. But the thing is, once you have the advantage of array is that key, once you have declared a particular array, the size of it is fixed. It doesn't matter key whether you're using it or whether you're not using it. For example, if I create 100, okay, let me write it here. I'm creating 100 size array, but I'm only using 5 elements of it, so the rest 95 elements are useless, like I'm not using them, but unnecessarily the space will get occupied. That's the thing, right? So you should be careful because the size of array is fixed. Okay, got it. So I hope you have understood key how array works and everything. Let me save it. Okay, now shall we go and see key how we can pass. One more thing we have forget before going into questions. We have studied functions, right? In lecture 1 we have shown you key how functions works and everything. So what I will do is that I'll create a function, and this function will print the array. So here I'll write public static void. Here let me go public static void main, not main, print array. Okay, so what this function will do is that it will print the arrays, whatever the array I am passing, it will print it. Now what I will do is that instead of writing this loop here, I'll just call my function. So I already know key passing a variable through a function is basically I'll write the function name, and in parentheses I'll give that particular variable. Similarly, we can pass the arrays in the same format. So I'll write print array, and I'll give the marks. Here what are marks? Marks is a array. So I'll pass the array, and this array will get passed to my function as a parameter, and using this parameter I'll change it. Okay, so this is one thing, and one more thing is that I want you guys to understand referencing or shallow copy, deep copy. So okay, I don't want to make it like really confusing for you guys, but shallow copy is that whatever the changes you are doing, that changes will reflect only in the array, only in the function, sorry, only in the function. But deep copy is something which will get reflected in the entire program. What is the meaning of this? Okay, I'll show you the meaning, but for now I'm passing it I'm passing my array to this particular function, and this function is printing the array. Now what we will do is that let me clear this and let me run my loop. So here I will give 100, 99, 98, 80 and 88. Okay, and 99 something. Why it's not printing? I think I haven't saved it. That's my bad. That's my bad. I need to save it. Okay, so kill this. How to terminate this? Okay, clear, and I'll write Java introduction public static void. I need to give space here, space, and save it. Now let me run it. So here I'll give 99, 98, 80, 90, 3 subjects, 5 subjects, right? So 80, 88 and 99. Yeah, clear. Why this thing is not working? I'm passing it print array, and here print array. Yeah, it should work, right? So okay, my bad. Here I have given 100. Oh god. So let me make it two elements. So control C, 2 elements. Let me save it and now run it. It will work now. So 1, 2. You will see printing marks 1, 2. Now there's a concept called as shallow copy, deep copy. Shallow copy is basically, let's say, along with this element I'm passing int a. Okay, now after this I'm writing int a is equals to 10. Okay, now here let me remove this. I don't need to give int. try to understand what I'm trying to tell, right? So here I'll give 20, or you can say a value. So we don't have a, right? Let me create a. Int a is equals to 20. Okay, got it. Now after this I'm printing system dot out dot print a value, and after that let's say I'm printing the last element. So system dot out dot print and marks of 0. Okay, now try to understand key. Let's say after printing it I'm changing marks of 0 is equals to 0. Okay, now what I'm doing, let me explain you the meaning of shallow and deep copy. Before that, let me save the program and run it. So here it is showing marks of 0 is equals to can't find symbol. Here I need to give ARR of 0, my bad. ARR of 0, save it. It happens when you are in very energetic mode, you made mistakes. So here our program has started. What I'm doing in my program, I'm running a loop, and in the loop I'm storing the values. Okay, so here I am going to give the first element as 100. After that 200. That's it. Two elements. Here marks of 0 is 100, marks of 1 is 200. When I enter now, you will see that I'm calling my function print array. Okay, and I'm printing the array. So the first element is 100, I got 100. The next element is 200, I got 200. Now after this I'm changing the value of AR of 0 is equals to 0. So in the place of 100, I have changed it to 0. Okay, got it. Now after that, I'm changing the value of A, which is 20. Now it will be 10. Now after this, after doing this function, after like executing this function, I'm coming back to my program and I'm printing the value of A. So here you can see I have changed it to 10, but my output gave me, when I'm printing system.out.print A, my output gave me 20. Okay, now again when I'm printing marks of 0, I'm getting 0. Why is that? Because when you are passing a variable, what will happen is that you will not directly pass that variable. You will create a copy of that variable and you will give this copy to the function. So whatever the changes you are doing in the function will not get reflected in the main program. That is why the value of a have not changed. Okay, but when it comes to array, we will not create any copy. We'll directly give the original array. That is why whatever the changes you are doing in the function, those changes will get reflected in the main program also. So for variables, the changes is limited to that particular function. This is known as shallow copy. Whereas when you send an array, that particular thing will get reflected in the entire program. We call that as a deep copy. Okay, we'll study this in detail when we study time complexity and space complexity. So this is pretty much it. We have understood the entirety concept of how to create an array, how to use them, how to give input, how to take input, how to access elements, right? Size of the element, what are the advantages, disadvantages, and everything. Now let's proceed with teeny tiny simple questions, logical questions. So let us do 2-3 simple questions, and after that we'll wind up the session. And in Thursday's class we'll do top important questions on arrays. So let me create a file, array capital, array questions 1 dot Java. I know I'm creating very big file names, but it has become a habit of mine. So import Java dot util dot star, my boilerplate code. After that, I'll write my class. Now what I will do is that I'll remove all these things. Okay. Now let me write the function for searching. Okay, we are gonna do 2-3 questions in. I hope you have understood how this entire concept works for array. Now we are going forward with questions. So in questions, the first we'll try to do mini teeny tiny questions. After it, in the next class, hopefully we'll start with deep questions. So the first question we are gonna see is linear search. Linear search. After that, largest elements. Third question will be, I have a list of questions. I can't remember. Like reversing array, reversal of array, a reversal without extra memory. Fourth question will be binary search. And fifth question will be pairs in arrays. We'll solve this 5 questions in this class, and hopefully in the next class we'll dive into Kadan's algorithm, subarray sum, printing subarrays, water trapping question. Yeah. So the first question is linear search. In linear search, we will be given a array, let's say 90, 98, 100 and 0, and along with the array, user will give us a key value. Let's say key is 100. Now we need to tell that whether this particular key is present in the array or not. If it is present, then we need to return the index of that array. If not, then return -1. So what will be the logic of this? If you see the array, let's see the array 90, 98 and 100. 100, 0. This is our array, right? Okay, indexing is 0, 1, 2, 3. Linear search tells that you go to each and every element and compare it to the key. If that particular element has matched with the key, immediately return the index. If not, then iterate to the next element. And if you have iterated the entire array, but you still haven't found the element, then return -1. So what we'll do is that here we'll run a loop. We'll run a loop for I is equals to 0 to the size of the array. What is the function? How we can tell what is the size of the array? So for that we have a function called as arr dot length. I will give the size of the function, size of the array, sorry, not function, array. So we'll write arr dot length. Okay, in this what we'll do is that if our key is equals to arr of that particular ith value, we already know how to access elements. If this is the case, then immediately return the ith index, or else continue. And after completing the entire loop, still you haven't find the element, it is an indication that the element is not present. In that case, you will return -1. Okay, so we'll start our iteration. Let me do a little dry run. I is equals to 0 initially. So what is the size of the array? The size is 4. So here I will run my loop from 0 to 4. Okay, now IRR of ERR of 0 is 90. So here you can see key is 100, but the ARR of 0 is 90. Okay, clearly these two are not matching. If this is the case, I will increment it. I'll increment I. Now ARR of 1 is 98. Again, not matching. I will increment it. ARR of 2 is 100, and our key is also 100. Both are getting matched. If both are getting matched, what I will do, I will just immediately return the ith value. What is the ith value? I value is 2, so I will return 2. Like this, our linear search will happen. So let me write the code first. I'll create a function, public static return. We are returning, or let me just print it, right? Void. If you don't have any idea how to create functions, and I recommend you guys to check out the playlist of Java. Okay, in that we have explained it in a very clear manner. So let me write linear search, and you can see if the key is present, key at index, and I am returning the particular element. Now after that, if it is not found, I am showing key is not found. Okay, now here I will create array int ARR is equals to this, and let me just write it. It is giving me everything. Okay, I'm calling linear search. Okay, so here we have element 23, 45, 12, 67, and this. So let me save it and run the file java array questions question1 dot java. Click enter to showing file name. Let me just, I should give the file name as little smaller all the time. Yeah, java here. Yeah, it is working. So let me put it in a full screen. The elements we are having is 23, 45, 12, 67, 34, 89. Now here, let's say I want to search the index of 12. So 0, 1, 2, it will give me 2. Let me see. You can see key is found at 2. Now when I run it again now, let's say I am running 0. 0 is not element in the array, so it should give me key not found. Like this we perform binary search. Now very similar to binary search, there is something called as very similar to linear search, there is something called as binary search. So in binary search, what we'll do is that we break down array into different parts. First of all, I'll tell you the theory part of that. After that, we'll move into the coding. So let me show you how things work. Okay, the next question is binary search, right? Okay, let's do one thing. In this class, we'll cover linear search, binary search, largest element. In the next class, we'll cover reversal, pace, subarrayism, Kadans algorithm, these things. Only questions. This let it be, this session be a little theory and some coding. Okay, so in binary search, what we will do is that binary search is very similar to linear search. Okay, it is also used to find whether a particular key is present in the array or not, right? But the only thing you should always keep in mind is that binary search is only applicable on sorted array. Okay, you cannot apply binary search on an unsorted array. Now how binary search works, we use 3 iterators, basically 3 variables, and every time we break down array into different parts, and in that part only we will perform searching. So how we perform binary search is that, let's say I have a element 90, 92, 93, and 0, 1, 2. Yeah, okay, let's say this is the only element I'm having. Okay, now the index is 0, 1, 2. So what I will do is that I will create an iterator int start is equals to my 0th element. After that, int end is equals to ARR dot length minus 1, because the last index is always less than minus 1 than my size of the array. So here the size is 3 and the last index is 2. So this represents starting and this represents ending. Now let's say my key is 93. Okay, now what we will do is that we will run a while loop we'll run a while loop while my starting is less than or equals to my ending. If this is the case, first of all we'll calculate mid value. So int mid is equals to starting plus ending divided by 2. Okay, now after this we'll see whether the particular element is equivalent to my mid value or not. So if ARR of mid is equals to key, if this is the case, I will return the mid value. So if this is not the case, else if ARR of mid is less than my key, it means that in the array my middle value is something here and my key is here. So in this case, if this is the case, my mid is on left side, in this case I'll change the starting value. So my starting value will become starting is equals to mid plus 1. Okay, now else if my ARR of mid is greater than key, it means that this is my array and here this is my key and my mid lies somewhere here. If this is the case, then I will take my mid near to my key. So here I will change the end value. End is equals to mid minus 1. Like this I will do, and I will keep on running this iteration until and unless this condition becomes false. If this condition is false and still I haven't found my element, then I will print or return -1. This is how our binary search works. So let me write the code for binary search as well, but the only thing is binary search happens only on sorted elements. So here I'll write a program, public static void binary search. So here this is the code. I am calculating mid value, this everything, and if not found I am giving not found, and this is a element for int binary search. I am writing a sorted array. So binary SEARCH search array is equals to, and I should give a sorted element. You can see I'm getting sorted elements. Now I will write int binary search key is equal to, let's say, 34, and I'm calling my binary search. Let me comment these things. You don't have to worry, that this entire code will be available on GitHub. I will be pushing it to GitHub. Okay, you can go to my personal GitHub and you can see that. So let me save the program before I run it, and when I run it you can see for 34 the index is 2. Like this binary search will work. Now the next question is very simple, calculating the largest element in the given array. This will be the last problem of this class. In the next class we'll move to array problems. Okay, got it. So the next question is largest element present in the array. So let's say this is our array 98, 100, 0, 1. This is our array. Now what we'll do is that the logic for finding, we already know the largest element is 100 and its index is 0, 1, 2, 3. The index is 1. So our answer would be 1 or the element itself, which is 100. Now the logic of this thing would be, we'll create minus infinity and we'll compare it. Okay, we'll create minus infinity and we'll compare whether it is a maximum value or not. If it is not, then we'll change the value. So first of all I'll run a loop. Before that I'll create int math value, maximum value is equals to integer dot min value. So what this will do is that I will take minus infinity. Now I will run my loop for I is equals to 0 to my size of the array. In this, I will check whether if my current element AR of I is less than, is greater than my, not less than, greater than my max element. If this is the case, I will update the max element. Max is equals to AR of I. Like this, I'll get the maximum element present in the array. So let me like do a dry run, little dry run. So I is equals to 0. My max value will be minus infinity initially. Okay. So ARR of 0, which is 98, is greater than minus infinity, right? If this is the case, then I will change it to 98. Okay, I will change it to that particular element. Now I will increment the I value 1. Now here AR of 1 is 100 and 100 is greater than 98. If this is the case, I will update the maximum value. I will update it to 100 and I will increment I. I value I have incremented to 2. So ARR of 2 is equals to 0. 0 is not greater than 100. If this is the case, continue to the next element, AR of 3. AR of 3 is equals to 1. 1 is not greater than 100. If this is the case, again continue. Like this, we perform largest element. This is how we find the largest element in the given array. Now let me go here and write it. So I'll write function again, public static. Here I need to use small p, not capital P. So public static void largest element, and you can see like this I'm doing same code. Whatever I have implemented, the same code is here. And if I write the largest element and I'm passing my ARR, you can see in this case the largest element is 67. So I should get the element present in that particular array as 67. So let me save it. Let me comment these two things as well. Okay, and this thing as well. Okay, now save and run again. So you can see the largest element, oh sorry, 89 is the largest element. Largest element is 89. Like this, we run our program to find the largest element. So till now we have understood key what is array, how to create it, how to use it, advantages, disadvantages, and we did 3 questions: linear search, binary search, largest element. So I don't want to make it into a 1 hour video, so I'll stop it here. But in the next lecture we'll learn about what are subarray sum, pairs of subarray, Kadam's algorithm, trapping water, stock market question. There are some popular questions, so we'll do 5 to 6 questions in the next chapter, in the next lecture. So with that being said, I will see you in the next one. Bye.